Welcome back to Rock the JVM, folks. This is Daniel, and you are watching Slick Tutorial with Scala Part 3. We're going to continue where we left off in the previous video with some advanced Slick features. So let's come back to the project where we left off in the previous video, and I'm going to walk you through what we have in the project so that you remember where we left off in the previous video. So this is a plain IntelliJ project built out of SBT, and here under build.sbt you have all the library definitions that we're ever going to need in this mini-series. You can also find them in the blog post, the written form of this long-form tutorial, which you can find in the link in the description of this video, so you can take the library definitions and paste them into your own build.sbt project if you haven't done so already. We have a Docker compose YML file because we're going to spin up a database locally as an independent Docker-based service, and we're going to use Postgres in this tutorial. And the Docker compose YML contents are also available in the blog post if you want to check those out, as well as some initializing scripts so that when the Docker container starts up, we already have some existing tables set up for us. And the use case that I'm demonstrating here in this long-form tutorial is something that relates to movies, actors, and kind of a fictitious movie database. So we have some tables relating to movies, actors, actor mapping, because we can have multiple actors in the same movie, and each actor can act in multiple movies. We have streaming movie provider mapping, movie locations, properties, and some actor details if we want to enhance the data that is available to us. At the same time, we have an application.com file under source main resources. This application.com file will be fetched by Slick in order to create the appropriate connection pool to connect to the Postgres database. And the source main Scala under this package com.rockthejvm contains the code that we wrote in the previous couple of videos. I strongly recommend that you start from the beginning if you're seeing this project for the first time, because we have a lot of things happening behind the scenes, and I explain every single bit that I added in this little project because I started it from scratch. I'm going to walk you through real quick. Under the connection object, we have a database object that will contain the entry point for most of our APIs that we're going to use in this video. So this database object will be used to execute our Slick so-called commands that will translate to actual SQL queries that will be run on top of the database. Then here under model, we have the data structures that we have so far. We have a case class called movie, a case class called actor, and a case class for mapping movies to actors. And each of these case classes has a corresponding table in the Postgres database. Now, in order to be able to map the appropriate case classes to the Postgres tables, we have this object called Slick tables, and we follow a simple pattern, which you can see here for one table that we replicated for all the other tables in order for Slick to map the appropriate Postgres table to our case classes so that when we run our queries, they're all type safe. And the pattern that we follow was to create a class with the name movie table. So we have the case class name followed up by the suffix table. This class takes a tag as a constructor argument, and this extends the Postgres built-in table type, typed with the case class that we want to map. With that tag as the constructor arguments, this is the schema name, which is the prefix movies for all of our tables. So if you look at the index strips, notice that all of our tables are prefixed with the schema name movies. And the table name that is going to be mapped in Postgres, and this must be the exact same name that we have in the Postgres table. Now, for every single table that we create, I created 3 or 4 or as many methods as was necessary for every case class. So for the movie case class, we had 4 members, so we had 4 methods here in the movie table, named identically as the case class, and we created these column objects, which we then use to override the star method, which is the mapping function to the case class. Given the tuple of the column objects, we are going to construct a movie, and we're going to deconstruct a movie case class into these tuples if we want to ever write a record to the case class. And after we defined the class mapping the table, we also created a table query of that particular type so that we can actually insert or fetch records from the database. And this pattern we followed for all the other case classes that we have so far. Now, in the previous videos, I showed you the essential create, read, update, and delete operations on the database, and I showed you some methods to run such queries onto the database. And in the previous video, I showed you some more advanced Slick features in the form of transactional queries, joins, and executing arbitrary queries as strings. Now, in this video, I'm going to show you how to map your own data types for the fields in the records of the tables. And in particular, I'm going to show you enumerations. And we're going to write Scala 2, so I'm also going to show you how you can define enumerations in Scala 2. At the moment of this recording, Slick does not offer support for Scala 3. It is in progress, but it might take a little while. So I'm going to show you enumerations in Scala 2. And also, I'm going to show you how you can generate the SQL initializing script for existing table definitions. So without further ado, let me show you the first Slick feature that I wanted for this video, which is how to map enumerations for fields in the records. And in this instance, I'm going to assume that a movie may have a streaming provider that is mostly available on. So I'm going to create a new type that I'm going to denote as an enum in Scala 2 that will be an enumeration for all the streaming providers that we might offer for our little fictitious movie database. So I'm going to create an object. I'm going to call this streaming service or streaming provider, and this extends a special type in Scala 2 called enumeration. Now, in Scala 2, defining enumerations is quite clunky because there's no first-class support for enums. This is fixed in Scala 3, but as I mentioned, Slick will take a little while before it offers support for Scala 3, given the fact that it's based on macros. So I'm going to show you how you define an enumeration in Scala 2. First of all, we need to define a type alias. I'm going to call this provider, or streaming provider, or something like that. And this is equal to value. And the value type is a type that is treated in a special way by the compiler to deconstruct these values into Java or JVM native enums. So this is what this value does. And the provider thing will help us define some new instances for these streaming services. And I'm going to show you how to do that. For example, if I want to define a value called Netflix as value of type Netflix, and the string is the name of the value, and I'm going to have my val, let's call this Disney, as value with Disney, or Disney Plus, and I'm going to have my value, let's call this Prime, the Amazon Prime one, so I'm going to have value with Prime, and maybe if you're interested in Hulu, I'm going to have value for Hulu. Now, the reason why we're doing this enumeration is that we're going to expose the type streaming service.provider, and we're going to be able to use these services as of type streaming service.provider. I'm going to show you how. Now, because there is a many-to-many relationship between movies and streaming providers, I'm going to assume a case class. So a case class. I'm going to call this streaming provider mapping. In the same style as we did earlier with movie actor mapping, I'm going to have an ID of type long, a movie ID, which is of type long, and the streaming provider as of type streaming service.provider. Because we can have one movie being available on multiple providers, and every provider obviously offers multiple movies. Right, so given the fact that we have a case class now, we need to create a case class mapping table for Slick, and we're going to follow the same pattern as we did before. So I'm going to have my streaming service mapping, and I'm going to define a class that I'm going to call this streaming provider mapping table with a tag as tag, and this tag is a type that is available in Slick, and this is automatically assigned when this class is being instantiated, and this extends table of type streaming provider mapping, so I've copied that. With the tag, the schema is called sum movies, as with the other tables, and the table name must be identical to the one that we have in the init scripts.sql. So streaming provider mapping. I'm going to copy that, and I'm going to paste it here in the streaming provider mapping table as a string. Right, now because this thing extends table, we need to override the mapping function star. Now, first of all, we need to have the column names. So we are going to have a def ID, which is a column of type long. This is the identifier of every record. And this is going to have the name ID, which is identical to the one in init scripts. So we have ID here. So this column name needs to be identical to the one that I add inside. So a column of type long with the name ID. Now we need to add a bunch of properties, which is primary key and auto increment if we insert without an ID. So these properties I explained in the first video in the mini series, what this thing does. And I'm going to have my movie ID. So I'm going to take this other definition because I have it really handy in the movie actor mapping table. So column long with the name movie ID. This is the same in the table. So let me go back. So we have movie ID big int. And the streaming provider now has a different type. It's not a string, it's not a long, but it's one of these enumeration values. And this is the feature that I wanted to show you. So I'm going to define a function that's called streaming provider. This is the same as the field in the case class. This is not mandatory, but I follow this as a pattern. And this is going to be a column of type streaming service dot provider. And the name of the column is going to be streaming provider. So streaming underscore provider to match the name in the column of the SQL file. Now, notice that in this case, we can easily build a column of type long, column of type string, and of any built-in type in the Scala language, but we cannot really build a column of the type that is denoted by us as an enumeration. We need some sort of conversion functionality here in the form of an implicit. So notice that we need to find an implicit of typed type of type streaming service provider. Now, I'm going to create that particular implicit in the following way. So I'm going to have my implicit val. I'm going to call this provider mapper. And I'm going to use the following structure. I'm going to have mapped column type dot base. And this base function denotes a conversion between a regular data type that Slick knows how to interpret, such as long or string, and the provider or the type that I want to convert to and from. So the base method will take the type streaming service dot provider, my destination type, and the base type is going to be string. So I want to be able to parse strings into providers and vice versa if I ever want to add a provider into a record. So this is going to be a conversion function to and from provider and string, or between provider and string. So I need to add two conversion methods from provider to a string. So I'm going to have provider dot toString, and a backwards conversion from a string to a provider. So I'm going to have my streaming service dot with name string. Okay, so given this provider mapper, this is a base column type of type whatever. I'm not actually going to add the type signature because it's quite complex, but notice that the column constructor here doesn't require any more implicits from me. Now, given the ID, movie ID, and streaming provider columns, I can now build the mapping function star. So I'm going to have my override def star. This is going to be a tuple between these column objects, which is ID, movie ID, and streaming provider. And then I'm going to use this funky method less than greater than, and I'm going to pass two functions, one to build a streaming provider mapping. So I'm going to use the name here, streaming provider dot tupled. That will allow me to create an instance of this class out of a tuple of long, and streaming service dot provider, and a backwards conversion function between a streaming provider mapping instance and a tuple of ID, movie ID, and streaming provider. So I'm going to use unapply because case classes will provide this right off the bat. So notice that once I've added this mapping function, the streaming provider mapping table is complete. The next thing that I need to add in order to make this complete so that we can actually add some instances into the table is going to be a lazy val. So lazy val, I'm going to call this streaming provider mapping table as table query of type streaming provider mapping table. And with that, we should be able to add streaming providers to our little database. Good. Now, let's go back to our main application, which contains all the demonstrations that I added in the previous couple of videos. And at the top, first of all, I'm going to add a bunch of associations there. So I'm going to have my providers associations as a list. And I'm going to use a streaming provider mapping with the ID, let's say 0, so 0L. Then we need the movie ID, which is, let's say, Shawshank Redemption, want to add it to Netflix. So I'm going to have my 1L, and I'm going to add streaming service.netflix. Then I'm going to add a bunch more. So I'm going to have streaming provider mapping with 1L, and then we're going to say that the matrix is also on Netflix. Then I'm going to add Star Wars to Disney, let's say. So the ID 2, the movie is 10L. This is the ID of the movie. Then I'm going to have the Star Wars Menace, the Star Wars A Phantom Menace. We're going to add it to Disney. And that should be enough. And let me go add another method here. So add streaming providers. And I'm going to have a simple query here. So I'm going to say insert query as slick tables dot, and I'm going to have my streaming provider mapping table, and I'm going to say ++ equals, then I'm going to use the streaming providers list, the providers mapping that I have there. So I'm going to have providers. All right, so this action here will translate into an insert statement where we're going to insert multiple records in the table. And then I'm going to say connection.db.run, and I'm going to say insert query. And that'll be it. So I'm going to use streaming providers here in main. So I'm going to take that out, and I'm going to simply call add streaming providers here in main. And before I run this application, I need to make sure that my database is up and running. So navigate to a terminal window and go to the directory where you had your project, and run this command docker-compose up. In the previous couple of videos, I already added the necessary configurations for the database, which also include the tables. And in the previous couple of videos, I also added a bunch of data. We're going to inspect that shortly. Now, in another terminal window, no matter where you are in that terminal window, you can do docker ps to find out the name of the Docker container holding the database, and then run docker exec-it, then paste that, and run the command psql-U Postgres. This will connect to the Postgres database via the psql command through the user Postgres. This is what this command means. And at this point, we should be greeted with a command prompt from Postgres, and we are going to have a table that's currently empty. So if I try to select star from movies.streaming provider mapping, I'm actually going to copy this one. So I'm going to select star from this thing. Notice that we have an empty table. The tables are already set up because the init script SQL is mounted into the Docker container, which already builds the necessary tables, which is now a good point or a good time for my main application to run. So I'm going to navigate back to main, and I'm going to run this application. Let's see what happens. It takes a little while to compile because we have quite a bunch of implicits and all that good stuff. Right, so at this point, the application should have run, and after 5 seconds, the application shuts down. And if I run this query again in Postgres, notice that at this point, we have some entries in the table, which means that our mapping function worked correctly. This is great. So we can also read data from the stream and providing mapping with our own data structures by running a similar command. So I'm going to have, let's say, find providers for movie, and I'm going to pass a movie ID as a long, and this is going to be a future of sequence of streaming provider mapping. And then I'm going to run a query. So I'm going to have my query as slick tables dot streaming provider mapping table, and then I'm going to say filter, where underscore dot movie ID must be equal to movie ID. Now, notice that I'm using the triple equals method because this is the built-in Slick method that will translate to an actual where clause in the SQL statement. And then I'm going to obtain the future by saying connection.db.run, and then I'm going to say query.result. And this is going to be a future that will contain all the mappings for a particular movie. So I'm going to say find providers for movie, and I'm going to, let's say, try the 10L identifier for Star Wars. I'm actually going to try to select from the table to validate that I have it there. So I'm going to select star from movies.movie with quotes, because otherwise the movie name will not be case sensitive. And Star Wars The Phantom Menace, notice that it has movie ID number 4 actually, so I'm going to use that one instead of the 10. So I'm going to use find providers for movie 4L. This is the item that's actually in the table. Your data might differ, so make sure you use the right ID here. And then I'm going to say on complete, and then in case we get a success with providers, I'm going to then print line found providers, and then I'm going to use providers map, and I'm going to say underscore streaming provider, because I'm only interested in the names of the providers so that I know where to subscribe to. And in case I get a failure with some exception, let's say I'm going to print line query failed, and then I'm going to inject the exception inside. Cool, let's try this out. And found providers vector. All right, so we didn't find anything. And I think the reason is because I'm querying the movie ID from the movies table, which has absolutely no connection to the streaming movie mapping table, which I'm actually interrogating. So I'm going to use 10L here because that's what the movie ID says here under streaming movie mapping. I should probably update Phantom Menace with the ID 10L if I'm ever interested in doing a correct join there. So I'm going to run with 10L, and at this point we have vector Disney as required. Cool. Now the second feature that I wanted to show you for this video, and the last one, it should be pretty quick, is a way to support the generation of these tables if your schemas ever change, so that you can actually initialize the correct SQL scripts. So here under model, I'm going to add a small section here under slick tables. So the table generation scripts. And I'm going to have a val, I'm going to call this tables for the lack of a better name, and I'm going to use a list of the movie table, the actor table, the mapping between movies and actors, so movie actor mapping table, and the streaming provider service that I've just added. So we have 4 tables at the moment. Now, this is just a plain list of table queries. Now, given these table queries, I can create a value that is called DDL, coming from data definition language, and I'm going to do a tables.map, and I'm only interested in each table's schema, so I'm going to say _.schema, and this schema object contains all of the necessary description of the table, including the table name with the prefix and all the column names and types. So this is the schema object. And then I'm going to say reduce _++_. So these schemas can be combined into one giant schema. And this schema can be turned into a string. I'm actually going to create a small object here. I'm going to say generate, or let's call this table definition generator, and I'm going to type in a main method here, and all I'm going to do is I'm going to print line slicktables.ddl, and then I'm going to call a very interesting method create if not exists statements, which is an iterator of strings. So I'm going to use a make string, and I'm going to use a semicolon and a \n to generate the entire contents of whatever I want. So I'm going to run this simple application, which doesn't really connect to any database. This will simply generate the SQL statements necessary to create my little tables. So if your case class structure ever changes, and if you ever need to drop your database and restart it again, this is a pretty convenient method to create your table definitions with the exact correct data structure that maps to your new case classes. In fact, this initScripts.sql was actually generated with this tool. Alright folks, so this was part 3 of the Slick tutorial with Scala. I hope you liked this video, in which case I'd recommend that you subscribe to the channel for more videos like this. Check me out on Twitter and LinkedIn for fresh updates on upcoming material. And check out Rock the JVM. It's this awesome little site with everything you may ever need to learn in the Scala ecosystem, including functional programming tools like Zio and Cat's Effect, big data with Apache Spark, distributed systems with Akka, and so much more. I'm waiting for you there. Until next time, I'm Daniel, signing off.